for the task we have to hand in today, just to go through some of these here, you might want to do these out of order. If you're using graphing software right now, you can do that, and that would help you understand those parts right away. So what I'm going to try to do is I'm going to do one of each of these groups without the graphing technology, and then I'll show you how I would lay this out if I'm not using graphing technology, because you're gonna go out of order here, especially when I'm looking at this first one. My x-intercepts, well, what's going to make this whole fraction equal to 0? It's just whatever the top is going to be equal to 0. So that would just be that x is going to be equal to 0. Oop, that's my x-intercept. My y-intercept, we're going to plug in x is equal to 0, and we get 0 divided by 0 plus 3, which is going to be 0 over 3, which means my y-intercept is 0 as well. Almost always, whenever you have your x-intercept is 0, your y-intercept is going to be 0 as well, because they line up as points. Looking at my vertical asymptote, it's whatever makes my denominator equal to 0. So what would make x plus 3 equal to 0? Well, that's x is equal to negative 3. So that's my vertical asymptote. My horizontal asymptote, because my degrees on the numerator and the denominator are the same, I divide my leading coefficients, which means that it is at 1. So this is going to be y is equal to 1. So if I look at this now, knowing my vertical and horizontal asymptotes, I can actually figure out my domain and my range. So it's all the real numbers. Same with my range. It's all the real numbers such that. And here, the only number that I know it can't be for my range is 1. So y cannot be 1. And for my domain, x cannot be negative 3. So once you know the horizontal and vertical asymptotes, you can go straight to domain and range. To figure out your positive and your negative intervals, you do have to think about the graph of it, or know the graph of it. So here's my negative 3, here's my positive 1. Well, my x and y intercept are here at 0, 0. Well, that means then my graph has to go through it here, which means I'll be in the opposite diagonal there. So where is it negative? Well, it's negative from negative 3. It's every time x is greater than negative 3, but less than 0. Oh, that was negative. And my positive intervals are from negative infinity all the way to negative 3, not including it, and from 0 to positive infinity. And when we think about increasing or decreasing, it's tracing your pencil or your pen along this graph, and you always read left to right. So where is it where are all my y values increasing? Well, in this case, my interval of increase starts at negative infinity. Ooh, that's a terrible green. It starts at negative infinity, and it actually continues on, right? So it will go all the way to 3, negative 3, and it actually goes from negative 3 all the way to positive infinity. Now, we can't include negative 3 because that's a point it never ever touches. And then for my intervals of decrease, there are none this time. There are no places that my graph is going downward. If instead, let's just say, for instance, my picture looked like this, well, I would actually have 2 intervals of decrease and no intervals of increase. So it all depends on how the graph looks. So if it helps for now, use the graphing technology to go through that, so then you can help yourself through those pieces. And then there's my rough sketch of a graph at the bottom. This would be very similar. The only difference here is that my y is 2, and it's because my leading coefficients are 2 divided by 1. because the order of the two polynomials are exactly the same. So this is where all that first unit content comes in. And very similar here, we're just adding in different pieces. So you're going to have different x and y intercepts for some of them. So for this g of x, when you're going through it, your x-intercept is going to be x is equal to negative 1/3. Your y-intercept is going to be positive 1/3, because you have 0, the zeros kind of get rid of everything there. And my vertical asymptote is still going to be x is equal to negative 3. My horizontal asymptote this time is just 3, because the 3x divided by x. And very similar with what you're doing on these pieces here. Vertical asymptote is going to be x is equal to positive 1, and my horizontal asymptote is going to be y is equal to negative 1. So again, that helps you figure out your domain and range. This x-intercept is 0, my y-intercept is 0. And my horizontal asymptote here is positive 1. My vertical asymptote is still positive 1 as well. It's just the nice thing when you're looking at these graphs are, well, here's positive 1, here's positive 1, here's positive 1, here's negative 1. And because it goes through 0, 0, this is what this part looks like for this graph, whereas this one, because it goes through 0, 0, is going to look like this. If you look at them, because they're negative, one is negative and one is not, it is kind of the flipped version of those. They're reflected pictures of themselves, right? We talked about that with transformations in the first unit. There are reflections, and here's one of those reflections. And then the same thing, we're talking about our negative and positive intervals. When are the y values positive or negative? And then when we look at our intervals of increase and decrease, we read left to right. So the one on the left here, f at x, only has intervals of decrease, and the one on the right, g of x, only has intervals of increasing, because it never actually, the values are never going down. They're always increasing slowly. And if we had one, when we start dealing with, say, a quadratic one, so say it was one like this, to help you with seeing that, x plus 3, x minus 4. We know vertical asymptotes are negative 3 and positive 4. My horizontal asymptote is 0. My x-intercept, there is none. My y-intercept is at 1 over negative 1/12. So I'm drawing this picture. I have here negative 3, positive 4 here, and this is it. So it'll be like this, like this, like this, and like this. So if we look at my intervals of increase, it's from negative infinity all the way to that negative 3, and negative 3 all the way to 0. Because at this, right now we're going to say it's right at this this y-intercept, and then it comes back down. So then my decreasing ones, so if we watch through my pen here, these values are all getting bigger and bigger and bigger. These values are also getting bigger and bigger and bigger. And at this point here, or some point here, is when we're going to make that transition, and these are all getting smaller every time. The y values are now getting smaller. So it means my intervals of decrease are from 0 to positive 4 and positive 4 to positive infinity. So that's when you would have multiple different things showing up.